Okay, folks, this next problem is very similar to the last one, and we're asked to figure out where this function g of x is increasing or decreasing. Here's our function g of x. I went ahead and gave you the derivative in factored form. Okay, I do encourage you to, if you feel like you'd have trouble doing this, to practice putting the derivative of this function into this format and clean it up this way. So we're asked to figure out where g is increasing or decreasing. So what are we going to do? Well, let's go ahead and let's state the domain of g. And the domain of g is all real numbers except that x cannot equal 0, or it looks like 6 in this case. Okay? And then let's go ahead and give the critical numbers of g. That's all of the places where g prime of x is either 0 or undefined that we haven't already picked up in excluding the domain. So we've got critical numbers at x equals 4 and x equals 12. Those are the two critical numbers in this case. And we know that because we've got the derivative already in factored form. So then what do we do? Well, this is this new technique. And we're going to build a number line. And on the number line, we're going to put all the critical numbers of g. And we're going to put all the places where g was undefined. So we've got 0 is going to show up, and 4 is going to show up, and 6 is going to show up, and 12 is going to show up. But I think it's really important that we know why these are showing up. So this is because g, this is because g is undefined. But this is because g is this is a critical number. And here again we have g is undefined. And here we have 12 is a critical number. Okay. So then what did we do? Well, we made our number line. And on our number line, we put all the critical numbers or places where g was undefined. And now what are we going to do? We're going to take test points. So we need, in each of these regions created by our critical numbers and points where g is undefined, we need to put test points. Pick a test point. Now, you can pick whichever point you wish. It doesn't matter as long as it's from this particular interval. Okay. Then I'm going to plug each one of these into the derivative. So I'm going to take -1 and I'm going to plug it into this derivative function up here. Okay. So I'll do this one all the way through, but normally I won't do this. So this would be -1 minus 12 times -1 minus 4 all over -1 squared minus 1 minus 6 quantity squared. And if we clean this up, we get -13 times -5 all over, I hope you can see that, all over -1 squared is just 1, and that's -7 squared, which is 49. Okay. And so we get some value. Let's see here. That's 50, that's 65/49, which doesn't reduce. Okay. So notice I did plug my test point into the derivative, and I got 65/49. But the point that I want to make is I don't really care that the derivative at -1 is 65/49. -1 was just a test point. It was just a random point from within this interval here. And we found that the derivative there was 65/49. So what do I really care about? I just care about the sign of this derivative. So since the sign of the derivative is positive, the increasing decreasing test tells me the function's increasing on that interval. Okay. So from here on out, I'm not going to actually plug in the numbers. I'm just going to look at the sign. So if I plugged 1 into the first derivative, if we looked at g prime of 1, well, let's see here. We would have 1 minus 12, that would be -11. I don't care about that. It's negative. And then we have 1 minus 4. Again, that's a negative number. All over, that's a negative number being squared, and that's another negative number being squared. We've got in the numerator two negatives being multiplied together, whose product is positive. And everything in the denominator, in fact, we should note now, is always going to be positive because of this squared factor and this squared factor. So we get a positive expression, so the function continues increasing. Okay. If I were to plug in 5, notice that everything in the denominator is still positive. This factor, 5 minus 12, that's still negative, but this factor is now positive. So we've got a positive times a negative. all over a positive. So the sign of the first derivative at 5, and therefore for any point between 4 and 6, say 4.1 or 4.2, the sign of the derivative at 5, or for any point in that interval, is going to be negative, and so the function is decreasing on that interval. Okay. Likewise, if we plug in 7, everything in the denominator is positive. This factor is positive, but this factor is negative, and so that makes everything decreasing. But if I plug in 13, this factor is positive, this factor is positive, everything is positive, so we're increasing. So f is increasing on which intervals? Well, it's increasing from minus infinity to minus 1. Oops, excuse me, what did I just do, folks? I just made a mistake that I told you not to make. It's increasing from minus infinity to 0 using these columns that I've created as my dividing lines. And again from 0 to 4, and again from 12 to infinity. Okay? Now, notice that in the last instance, it's an important example to keep in mind, we had f was increasing from minus 2 to 0, and again from 0 to infinity, and I went ahead and grouped those two intervals together, saying, oh, it's increasing all the way from minus 2 to infinity. And that was because 0 was a critical number of f, but f was still defined there. Why did I not join together these two intervals? Because I mentioned that this number is on the number line because this is where g is undefined. Okay? Anyway, f is decreasing then on which intervals? From 4 to 6, and again from 6 to 12. So it's decreasing from 6 to 12 and decreasing from 4 to 6. Okay? Again, I can't join together these two intervals. Why? Because 6, this endpoint, is a place where the function was undefined. So in fact, if you were to graph this, which I'll have you do, it turns out there's a vertical asymptote there. Okay, so I can't join together those two intervals like I was able to join together these two intervals in the first example. Okay? So if you've got room, regardless, I'd like you to go to this website, sketch a graph of g of x. If you've got room to do it there, great. If not, just jot it down in a notebook. And I hope this example was helpful. Going forward, I'm going to have you repeat this procedure. You're going to do the whole thing now. You're going to find h's derivative, and you'll answer the question, where is h increasing, decreasing, for number 6. And I'll walk you through that, and then I'd like you to do the same thing again for number 7. So the videos will pick up again on number 8, but go ahead and finish out questions 6 and 7, 5, 6, and 7, I guess. Thank you.